now do another small sample test with averages. Ralph, an avid bowler, moves to a new city and wants to join a first-place bowling team, the Boomers, that happen to have an opening. Ralph tells them that he averages 195, and they ask him to bowl 5 games to verify this claim. His average score is 181.3 with a standard deviation of 19.6. Can the statistician with the Boomers disprove Ralph's claim? Use an alpha of 5%. Sample information: N is 5, average there of 181.3, standard deviation 19.6. So we're going to compare that to the 195. But this is not a two-tailed test, this is a one-tailed test, because when Ralph tells them that he averages 195, he means that he averages at least 195, because they're not going to have any problems with the fact if he bowls 198 or 200 or anything larger than 195. So this is a one-tailed test. So let's write down our sample data. Okay, so our sample data: N of 5, sample average there, X bar of 181.3, and sample standard deviation of 19.6. Alright, and essentially the claim, we have claim here, is that he bowls at least 195. Alright, we're going to test that claim. But the at least part, which is understood here, means that we're doing a one-tailed test. So again, our first question is, which tail? We get our sample data, X bar, the 181.3, and we're going to compare it to the fixed value in the claim, 195. 181.3 is less than 195, and so our t-calc is going to be negative, since it's going to be 181.3 minus 195, and that's a negative number. So a lower tail test, and the alternate will have that less than sign. So instead of X bar being less than 195, the population equivalent will be mu less than 195. Down both hypotheses. Let's do the alternate first, since we have that. U less than 195. Null will be mu greater than or equal to 195. And if the true average is greater than or equal to 195, Ralph's claim is correct. And conversely, if true average is less than 195, the claim is not correct. What we need to do now is to calculate our degrees of freedom, as we will do now with any averages problem, n minus 1. In this case, n is small value 5, so it's 4. Since that clearly is less than 30, we're going to use the t with 4 and do the small sample test. Now we can draw the distribution. Let's call this a t with 4 degrees of freedom. The middle of all these t distributions is 0. It's a lower tailed test with an alpha of 5%. Okay, so we're going to go to our t tables, look for t with 4 degrees of freedom and 5% in the one tail. 4 degrees of freedom, 5% in the one tail, and that's 2.132. But as our test here is a lower tail test, our critical value will be minus or negative 2.132. Decision rule will go as follows. If we get a calculated t-value above negative 2.132, it's possible the claim is correct. If we get a calculated t-value less than a negative 2.132, it is likely the claim is not correct. So let's now write down that decision rule. If t-calc is greater than or equal to the negative 2.132, null is possible. Do not reject the null. It's possible. Null is correct. Well, in this case, it's possible the claim is correct. Alternatively, if t-calc gets less than minus 2.132, we're now sufficiently far enough away from the hypothesized value that will reject the null and in its place accept the alternate and say that it is likely the claim is not correct. Now do our calculations. Calculations normally start with the standard deviation. This problem, S of x bar, S divided by the square of the sample size n. S is 19.6 divided by the square root of 5. Let's go to Excel and work that out. So this is equal to 19.6 divided by the square root of 5, and 4 places that's 8.765, and then the t-calc, which is x bar minus mu divided by S of x bar 181.3 minus mu, the value from the null hypothesis, the claimed value of 195, divided by the standard deviation 8.765. And now let's go back to Excel and work that out. So this is equal to 181.3 minus 195 divided by standard deviation, and we get minus 1.563. So we have minus or negative 1.563. Okay, that value is in the acceptance region, negative 1.563, clearly greater than the negative 2.132. So we will go with the first part of the decision rule, not to reject the null. It's possible the claim is correct. Decision: since t-calc is equal to the negative 563, and since that's greater than the negative 2.132, sample value is too close to call. We will say do not reject the null. And it is possible the claim is correct. And that's the end of this problem.